Hi everyone. My name is Yadav Lamishani, one of the organizer of the CNCF Kathmandu chapter. We are re-energizing the CNCF Kathmandu chapter with a series of events called CloudWeek Kathmandu, where we will be providing informative sessions on DevOps cloud native tools like Kubernetes, CI/CD, GitOps, etc. This event will be on weekly basis. So please check on our upcoming events, which we will be adding on our Meetup channel. In this episode, we will have two sessions. The first session will be on CNCF landscapes and open source contributions, which will be presented by the Saim Safder. He is a CNCF Ambassador and leading the Cloud Native Islamabad chapter. Accordingly, second session will be on the locals to KTS, which will be presented by Raju Dawadi. He is a Google developer expert and a lead organizer at CNCF Kathmandu chapter. For the Q&A session, we will be sharing the Google Docs link in the chat section. Please check out in the chat section and put your questions for the respective presenter. Without further ado, let's start the first session. Sam, the stage is yours.
Thank you very much for giving me this opportunity to talk about introduction to landscape on this channel. So can you give me a second while I share my screen as well. So if I'm unable to do so, so Raju or the maintainer of the website, but they can share as well. So Raju, can you share as well? I think you have the access to it as well.
Mm, I think you also should have access. Can you check?
Yes, I'm checking.
Yeah, because that will make it easier for switching the slide.
Yes, sure. So I hope you can see my screen now.
Yeah.
Yes.
Oh, okay, thank you. So please add, I don't see the chat now, but please put your question in the chat section now. So some of the maintainer or some of the host or actually organizer of the event can actually ask those as well. So let's start the agenda today. So we are starting about introduction to cloud native sense and how do you make sense of it. If you happen to be in the CNCF Landscape.com, you see this diagram with so many projects, so many tiles, so many concepts, so many open source communities, so many open source projects, so many words you never even heard before, and that's you might get really scary by navigating to this landscape. But my job is to let's zoom in to understand what's hidden within the each tiles and how this actually lay out, how it's got structured, and what is actually giving what this landscape is actually telling us. So who I am? My name is Saim Safder. I have a YouTube channel called Cloud Native Podcast, where you can find the awesome technical deep dive content related to all these landscapes projects you actually seen in a minute now. So go check that out, Cloud Native Podcast on YouTube, and that's where you can actually learn more about these topics. I'm also the co-founder of Cloud Native Islamabad. We also host meetup like this, but those are more technical, like a deep dive hands-on, and you can actually search in community.cncf.io/Islamabad. So without any further delay, let's talk about why we are here and what we are learning today. So in this talk, my job is to breaking down the mammoth landscape and provide a high-level overview of the entire landscape, its layers, columns, categories. Zooming into each layer and column provide us a more greater visibility on what each category is and what problem it solves and how it solves it. So if you look at the cloud native landscape, similar to this one, you can go to the CNCF landscape.cncf.io. This is the picture you will see. So within this landscape, this is actually providing us tiles with pre-description of some of the mentioned categories and the project listed in the specific domain. So we have domains called application definition and development. We have a domain called orchestration and management, runtime, provisioning, platform, observability, and analysis. Within the each domain, or which is the each column, or within the each row, you will find sub projects or sub domains. Within the runtime, you see cloud native storage, cloud native runtime, and cloud native network. Within the provisioning, you can see a subdomain called automation and configuration, container registry, security and compliance, and key management. Within the orchestration and management, you will see scheduling, coordinating service discovery, remote procedure call, service proxy, API gateway, and service mesh. And that is the structure and the layout is you actually seeing when you actually dive into the landscape of CNCF. So this is a high level overview, a 360-degree overview of what the each tile represent. Within the each tile, let's say we call databases, we have plethora of tools and plethora of open source projects and communities that actually managing those open source projects. So let's learn each category one by one. What is provisioning layer? We start with the provisioning layer. Remember, within that layer, we have automation and configuration, container registry, security and compliance, and key management. But what the name provisioning tells us here? Provisioning refers to the tools involving in creating and hardening the foundation of which cloud native applications are built. It covers everything from automating the creation, management, configuration of infrastructure. You can actually scan your code, you can sign your container images, and you can store your container images into the repository we now known as Docker Hub, Red Hat Quay, or Amazon Container Registry, or Azure Container Registry, or Google Container Registry, or GitHub Container Registry as well. So this is provisioning in a nutshell. Within the provisioning, you will find automation and configuration tools. These tools helps engineer build computing environment without human intervention. Remember, we have a tool called Terraform, and Terraform give you the infrastructure as code, meaning you can actually write the script that can help you define how your infrastructure look like within the cloud, within the cloud. Then the next section is called container registry. That is basically you store your artifact, container images, or your layer file structures, your Helm charts. All these things can be stored on the container registry. Within the security and compliance, you this is a security area. Basically, you define an organization-wide standard. Let's say me as a Saim, and I'm the team lead for some of the projects. Some of the people I'm listening to me right now. If I am the team lead within your team, and you're working alongside me, let's say we find organization standard say everybody can pull container images from Docker Hub, but can't pull images from Red Hat Quay. This is our organization wide policy. And for that policy to be implemented in a cost efficient way, we need a tooling, and those tooling will be a part of security and compliance. And remember, we have a key management. Key management is referred to as whenever you start working with your coding application, you have a scripting, you have your apps, you have databases, and databases require admin credential passwords. And there are so many other passwords we can actually list a few. But remember, we just talk about one of those, and that one is, let's say, password for interacting with Amazon Web Services. For those password to be managed automated way, you need a tool, let's say called HashiCorp Vault. And that Vault now become a key management under the provisioning layer in the cloud native landscape. The next layer is runtime. Within the runtime, we have cloud native storage, container runtime, and cloud native network. Within the runtime layer, runtime is one of those terms that I believe confusing. Like many IT terms, there's so many definitions, so many buzzwords, so many different opinions, so many different approaches to think about, and so many contexts. And I need to narrow down it. So now runtime is a sandbox on a specific machine prepared to run an app, the bare minimum an app need. Basically, you can consider if you are running a Python app, and for the Python, I need 3, 4 libraries. And those libraries is already baked into, let's say, my machine, and then I can run Python application on top of it. That's called a sandbox environment. And that we can refer to as a runtime. So you can call it those sandbox environment as runtime. In the CNCF landscape, runtime is defined somewhere in between, focusing on the component that matter for the containerized apps, in particular, what they need to run, remember, and communicate. And they include cloud native storage. If you have a microservices application and that application running in the form of the container, and remember when the container comes and dies, your storage loses. You need a persistent volume claim, storage classes, and much, much more. Implementing those by hand is significantly a different task. For that, you need tooling, and that tooling become a part of cloud native storage under the runtime row. Within the row, we call cloud native storage as a tile, and within that tile of cloud native storage, we have different projects and their logos visible here. And next, there's a container runtime. Remember, when you containerize your application, Docker is one of container runtime. It doesn't mean you always run your container using Docker. You might need Builder, you need Podman, you might have, let's say, Conico or KO. These are all the tools that will help you build a container and specifically can help you run container as well. Within the container runtime, we have Containerd, Docker is one of them, Cryo. And these are the three container runtime that help you run container. So that is the way, this is a place where you see the logos of Containerd, uh, Cryo, Rocket, and Docker. Within the microservices app, if you're working on the container application, you need cloud native networking to network to communicate over the nodes within the cluster, outside the cluster, within the premises of organization, and within the premises of outside the organization. If we're just talking about only the app, that are microservices in the form of container, for those container to communicate with each other, I need a networking, and that networking can be implemented via CNI, container network interfaces. For that interfaces, I have a project called Calico, Cillian, and bunch of other, but these are the most popular ones. For the orchestration and management layer, the word orchestration, I know it has a huge, different, there's so many different opinions, so many different aspects to think about it, so many aspects to think, generate a context around it. So, for simpler term, let's define the orchestration is basically give you an infrastructure, package up your application, run in the form of the container, and that's container now need a networking layer. They help create a networking layer as well, and that's container need to store data, and that storage is done via some tooling, and that tooling need to be bootstrapped while the container is up. And these are some of the tasks of the orchestrator, and that one of the orchestrator is Kubernetes. But what the definition tell us from here what orchestration and management layer means. Once you automate infrastructure, provisioning follows security, compliance standard, provisioning layer, and set up the tool that need to run runtime layer, engineer must figure out how to orchestrate and manage their app. The orchestration and management layer deals with how all containers, services, app controllers are managed as a group. Within the orchestration and management layer, you will find orchestration and scheduling. And that is where the most popular, the most liked, and the most taught tool within the ecosystem is Kubernetes. And Kubernetes is what makes a cluster by managing container and the operating environment. Basically, if you have 10 or 10,000 of container running simultaneously, remember if one of them is broke, you are losing your actual whole application might crashes, and your functionality doesn't uh, is not expected to work what we expected from him. So basically Kubernetes does is they allow all the container to communicate with each other, manage their databases, allow them to run on the provisioning layer, and set up some runtime layer so they can actually create container and delete container on the fly. So when your application is working within the Kubernetes, you need a service discovery. Service discovery mean if my one app is running on EC2 instance and another app is running on Azure Container Instances. These are the two separate microservices running on different cloud providers and might be living in a different geography. How do I communicate with those two different microservices? For that, I need a service discovery. For the service discovery, the tools we have Core DNS, Cube DNS, and there are a bunch of others as well. Also, when you work with the container, you interact with the tooling, with the underlined system. Like if I'm running containers on my Mac system, I need to communicate within my system to understand how the containers are built, deploy, running, or stop, or or resumed. So for that, I need a RPCs. For RPCs, we have different tools available, so you can look at it. That basically what that does is for the service proxy or the ingress controller, uh, we have traffic, Nginx, HA proxy, Kilma, Kong, and there are a bunch of other. Basically, when your app is running on the system, and Kubernetes doesn't give you the ability that the client from outside of the world can route the traffic within your container where the application is running. Within the cluster, and every app can talk on every other app within the same node, outside the different nodes, that can be manageable by Kubernetes. But outside the world of the cluster, nobody can interact with Kubernetes. For that, you need ingress controller. For the ingress controller, Kubernetes doesn't do anything, but they have classes that you can implement to create your own ingress controller. That's where you call Nginx, Kuma, Kong, or all these proxies begin. And then there's a new concept called API gateway. That is relatively a new concept within the ecosystem, but it's basically an abstraction layer for to which external application can communicate. So basically, it's doing the work of ingress controller, but basically it's allow more functionality, full customization support, and full fine grained tooling as well. The next section within the orchestration and management is called service meshes. So basically, the service meshes is allow you. Remember, we have a Kubernetes. Kubernetes, if within the one pod, you can run two containers. So if I want to decouple the logging code of my application to a sidecar, this will lift off the burden from the developer to implement the troubleshooting and the logging and the tracing of that application. For that, I need a tooling, and that tooling is called service meshes. So it's basically give you the sidecar proxy while you communicate within your application and within outside the application. And plus, remember this, when the microservices communicate with each other, you want to have a mutual TLS, transport layer security. The encryption from both sides is actually encrypted. When the communication happens between two channels, you want to make sure that communication go via the network are encrypted. That where service meshes is also allowed to help you. The most popular one, Istio, Linkerd, and HashiCorp console. The next layer is called the application definition and development layer. The application definition and development layer focusing on the tool that enable engineer to build app and allow them to the function. So basically under this category, you have databases enabling apps to collect data in an organized manner. And you need a streaming messaging. Like remember, we have Apache Kafka and we have other messaging servers available. Basically, what it allow to does that. Remember, if you have 3 million devices that actually generate messaging, it's very difficult to orchestrate those messaging. So you need a server where you can actually send the messages, and then the devices actually subscribe to this server, and then they actually populate the data over it. For those for those abstraction layer, we have tooling. With those tooling become a part of streaming and messaging. Next, we have application and image build. So I remember Docker can help you build images, but that is only one of the tools. Remember, Docker is not the only one. We have Podman, we have Builder, we have Conico, and we have Ko. All those become a part of application definition and image build. Then we have a continuous integration and continuous delivery. There are the remember, I think we are all familiar with the DevOps tooling that help you build, run, and deploy your application. For that, you need a tooling. For the tooling in the cloud native landscape, we have Tecton CD and we have Argo Workflow, Argo CD, Flux CD. All these become a part of the CI CD within the tile, either within the ecosystem. The next tooling that is one of my favorite part is monitoring, logging, and tracing. We collectively and combinedly called as observability and analysis. Observability and analysis are tools that monitor all layers. Platform, on the other hand, bundle multiple technology within these layers into one solution, including observability and analysis. So basically, we are referring here is when your application running in the production server, they communicate with different services within your application, and those services communicate with each other. How much the response actually takes when I talking to the API server and they're sending me the response back, that's called tracing. Remember, tracing means which service called which function within your programming application. Logging means whenever user actually calls your microservices, you actually log down the user entity and registered in your logging server that, let's say, the sign actually log into the API into the login service under which time and under a certain condition. And the monitoring is actually does you how your application works, how the server is communicating, and how your application behaves when talking to the different components within the same microservices architecture. So observability is basically allow you to limit service disruption to help drive MMRT, mean time to resolution. Now, how long it take when it breaks and when it's actually finally recover. How long it took time for the recovery. You will need to monitor and analyze every aspect of your application so any anomaly gets detected and rectified right away. Logging tools collect event logs. Matrix monitoring solution collects metrics, and tracing goes one step further than monitoring and monitor the propagation of user requests. This is relevant in the context of service meshes, as I communicated previously as well. And the chaos engineering is basically you actually know how the fault tolerance of my application of my system works. So basically, you break your system by generating more than thousands of requests within the limit of 1 or 2 or 3 minutes to check when it breaks, how it's actually respond and how it's recover when it actually breaks. So that's become a part of chaos engineering. For the logging, we have Fluent Bit. For the monitoring, we have Grafana and Prometheus and Thanos Matrix. For the tracing, we have Jagger. For the chaos engineering, we have Litmus Chaos and bunch of other tools within the CNCF ecosystem. So last is remember these are the individual tool, and you need in most of the time not one but the combination of these two. For this mean you need a platform. for the platform that have baked in these components and the technologies, and you use as a SaaS platform. So as we have seen, each of these modules solves a particular problem. Storage alone does not provide all you need to manage your apps. You will need an orchestration tool, container runtime, service discovery, networking, API gateway. Configuring and fine-tuning different modules so they are reliable and secure, and ensuring all the technology it leverages are updated, and vulnerability patches is no easy task. So basically, when your images are running in the production, it may find vulnerabilities, meaning some of the components are outdated, and you need a manually team to actually fix those patches. With platform, user don't need to worry about these data. And you will probably notice the categories all around revolves around Kubernetes. And that's where I talk about the shiny piece of Kubernetes. We have a Jenkins, we have live in the world where there are different tools and the different ecosystem exist. But within the ecosystem, there are separate communities that could not actually communicate with each other within each other communities, and that's where communication lapses, and different communities doing the same thing, which end up leading them to become a competitor. Within the Kubernetes community, we have a CNCF, and this help all the communities to become a part of Kubernetes. They look at the Kubernetes, look at the corner cases where Kubernetes doesn't provide solution. They look at their expertise, and then they actually come up with a tool that can integrate with Kubernetes, and this solves the community problem. And Kubernetes is one of those tools that communicate and integrate seamlessly well with all of the other tooling as well. So within the platform, we have Kubernetes distributions like K3s, K0s, Minikube, Kind, and bunch of others. Within the hosted Kubernetes, we have management platform called, you can call it EKS, AKS, GKE, and there are some companies who actually built it management solution around Kubernetes. Rafe is one of them, Rancher, OpenShift. These are the hosted Kubernetes solution. Then we have Kubernetes installers, and then we have PaaS and container services. So these two list on that category as well. So the key takeaway is, remember, there are different tools within the CNCF to aim to solve a specific problem. Some are pre-cloud technologies, cloud native technologies adapted to new reality, while others are completely new. Difference lie in their implementation and design. There is no perfect technology that checks all boxes. In most technologies, it's limited by design and architectural choices. There's always a trade-off when you use it. But if you are the student who want to contribute to these projects, you have so much to learn, and you have so much to explore, and actually you actually one step closer to becoming a recognized community member. If you look at the project, you learn what it does, you find corner cases where it doesn't fit in, talk to the communities worldwide, see how you can actually become a part of it, how you can actually contribute to these projects, and then remember, you can be a consultant in this domain, and that is where companies investing a lot of the time. With that, thank you very much for listening to my talk. Now I hand over to the organizer to look at the chat and see if any question being raised, and I can answer those. Over to you, Raju.
Thank you, Saim, for a wonderful insights on the CNCF landscape. I get to see a few questions raised for you regarding, okay, I'll be reciting the first questions. What are runtime specifications? Do all the container runtime use RunC under the hood, or are there any alternatives?
Runc. So basically, like, I think if you look at the Docker is actually one of those tools that really actually one of actually I think it's revolutionized the container industry. Like if you look at the Docker gives you image building. Docker gives you how to pull and push images to the container registry. Docker give you the opportunity to communicate with the SAR, ECR, PCR, and you can actually create container images locally by using the Docker commands and can push them into the container environment setup in the Azure Container Registry. So remember, Docker has a monolithic app that can do a bunch of other activities. The way Docker work is when you call a Docker using its CLI, and then CLI actually work with the Docker daemon. Docker daemon job is to build an image, and it do doesn't, and it's not a job of Docker daemon to run the image. Now it's lift off the opportunity to another component within the pipeline. That's component called container D. And then container D is not actually running the image. Container G is responsible pulling and pushing the images. The running the images is the opportunity where run C comes in. So run C is actually a container runtime. It's actually look at the container when the container is running. If it's stopped, paused, or delayed, it's actually shoot off the container. So if you talk about other technologies like Podman and Canico, build up, it's never important. Might be run C is not important for them. And remember, run C. Somebody wrote an application for C run, running a run C program as part of the C plus plus. So it's not every technology work like different, but the Docker is work like this way. Other technologies work in a different way. For the podman, they actually lift the container D. What container D does might be the run C they're using, might be the never using. It's up to the different implementation. So that's where the one question ends. And another question is how do we choose Kubernetes versus other orchestration tools for the project? I think if you look at the Kubernetes, the thing I like about Kubernetes is that Kubernetes knows that Kubernetes is not enough for you. Once again, I repeat this question. Kubernetes know from the day 01 that Kubernetes is not enough for you. Basically, what I'm trying to focusing here is if you want to deploy your application, and I want to use this application from the outside the browser, and I couldn't do so. I need an ingress controller. And Kubernetes knows people need to access application from the browser, but they don't have a functionality baked into it. They created an APIs that you can consume to build a solution for that. And that is actually meaning you always been in the Kubernetes without learning new technologies or new programming model. You're just using the Kubernetes to solve your day-to-day problem. If you're using the Nomad or Apache Mesos or other orchestrators, they don't have this kind of community. Meaning, if something is missing, you need to work harder to implement in Nomad and Apache Mesos, and then learning curve becomes so sophisticated. First, you need to learn how the Apache Mesos and Nomad work, run, and install, and then you actually know how to integrate with Mesos with other tooling as well. So Kubernetes is the preferable, not because it's complicated, but remember, being in a Kubernetes, you don't need to learn any other thing. You just need to familiar with kubectl command, and it's work in the most of the cases. Over to you now, Yadav.
Thank you, Sam, for your wonderful insights.